Hello everyone, welcome to Clean Coder YouTube channel. So in today's tutorial we are going to solve lead code problem number 1302, deepest leaves sum. So this is a lead code medium problem. So let's go through the problem statement quickly. So it says, given the root of a binary tree, return the sum of values of its deepest leaves. Although the problem statement is quite self-explanatory, I'll give you a brief idea like what the output is expected. So a binary tree similar to this would be passed to us, and we are supposed to return the deepest level sum. So deepest level of this binary tree is the last level. So the sum of the nodes which is expected to be returned is 7 plus 8. 7 plus 8 is equal to 15. So this is our answer. So similarly in example 2, the output would be 19. So let's have a look at the constraints. The number of nodes in the tree is in the range 1 to 10 raised to power 4. Okay. And nodes value is between 1 to 100. Cool. So let's move to our whiteboard to analyze the problem in more depth. So in the interest of time, I have already copied that example to better demonstrate it here. So what is expected out of us is that we'll be returning the sum of the last level. Okay, this is the last level. So 7 plus 8 is equals to 15. So this sum we are supposed to return. So the tree could be like this also. Okay. So in that case the sum would be 4 plus 5 plus 6 plus 7. This would, whatever be the answer, this would be the answer in that case. Okay, so let's discuss the solution approaches which we can use to solve this problem. Okay, so there are two approaches possible, obviously recursive and iterative solution. So recursive solution we'll be going through in this tutorial. I'll also try to make a separate tutorial on iterative solution, which is based on BFS mainly. So if you are watching this video little after the release of this video, feel free to check the description box, because most probably the iterative solution would be linked there. So let's jump to the recursive solution in this video, and let's discuss the algorithm. Okay, so the algorithm for recursive solution is quite straightforward. In the first step, we are going to compute the height of the binary tree. Okay, so if this is the binary tree, so its height would give me the deepest levels in the binary tree. So height of this binary tree is 2. So the number of levels in this binary tree would also be 2. Okay, so this is the first level, this is the second level. So height would give me the number of levels. So in the step 1 we are going to compute that. So now this computed height we are going to use in the step 2. Let's see what step 2 says. Step 2 says recursively add node values of deepest level only, and also maintain the max sum. So what it is trying to say is that, assuming this is my given input, right? So what it says is, first of all, compute the number of levels in this binary tree. So number of levels from the previous step we already know is 2. So the deepest level, this is level 1, this is level 2. So it says in the deepest level, compute the sum of the nodes recursively. So we'll maintain a counter. Whenever we go in depth, we are going to increment that counter. So when that counter would be equal to number of levels, we are going to increment our sum. So in this case, the answer would be 2 plus 3, which would be 5. Okay, don't worry, like we'll be going through detailed code simulation, so you will get a better understanding for sure in the next step. Okay, so there are only 2 steps in this algorithm. Let's move to the code walkthrough part. Okay, so this is our code walkthrough. I'll quickly go through the code first, and then I'll simulate this code on this sample input, and hopefully you'll get a really good idea of the recursive solution of the problem. Okay, so this is the function given to us which we are supposed to complete, and we are given a root of the binary tree. So if the binary tree is null, this is the base condition, we can directly return 0. So if the binary tree has only single node, then that node is actually the deepest level, and we can directly return its value. So these are the 2 base conditions. So the next step is the finding the number of levels in the binary tree. Okay, so we are going to find the deepest level using this recursive function recur. So this is nothing but finding the deepest level of the binary tree, deepest level of binary tree. Okay, this recur function is written here. This is really simple function. So if you take a look at this recursive solution, what it is doing is, it is doing nothing but similar to a post order kind of traversal, and what this is doing is basically capturing the maximum height from left child comma right child and then adding 1 to it. Like if I simulate this function on this example, what would happen is that please watch carefully. So in post order traversal, it would go to the deepest level first. So it will start from 1, then it will go to 2, then it will go to 4. So the 4, like when it will hit root dot left for 4, 0 would be returned. Okay, and similarly when it will hit root dot right for 4, again 0 would be hit. So mat root maximum of 0 comma 0 is 0, and if we add 1 to it, so a 1 value would be returned from here. Okay, so going with similar process for 2, the right would return 0 and left would return 1. So we are taking maximum of 1 comma 0 and adding 1. So this is nothing but 2. So this would get 2. Okay, using similar reasoning, this would return 1, and what this root node would return. Okay, this root node is going to return maximum of left comma right plus 1. Okay, so maximum of 2 comma 1 plus 1. Okay, which is 3. So the number of levels in this binary tree is 3. This I have written here already. So the depth of this binary tree is 3. So this recur function would return 3. Okay, let's clean up a little bit so that we can simulate the recursion in the next step also. So this is 3. Okay, so this is 3. Now let's see what is next in our algorithm. So I have taken some array of size 1. This is nothing but for pass by reference. So in Java, if you want to persist a value between recursive calls, you need to either make a class reference or you can use an array of size 1 for that. So this is a quick hack which you can use. Otherwise, feel free to make a separate class also, a wrapper class kind of thing. So after that, we are on this line, deep sum. Root is this root of this binary tree. Deepest level is what we got. We are passing 3 and 1. Now this is interesting. So 1 is nothing but we are starting from the level 1. So it is just saying that level 1. So sum, what is sum? Sum is 0 initially. Okay, sum is 0 initially. Let's move to the deep sum function now. It will come here. Now what this function will do is, this function is really simple. It is a pre-order kind of traversal, like the logic is written before recursive calls. Okay, so this is pre-order kind of traversal. So initially my level is 1. Okay, so the deepest level is 3. So this condition won't execute, so it will go in the recursive calls, like it will reach this. Okay, so at this stage my level is 3 and deepest level is also 3. So what it will do is it will add this value to sum. So sum was initially 0, so it will update sum from 0 to 4. Okay, and return. So there is only a single deepest level, like there is only one node at the deepest level 3, which is 4 only. So this recursion would go to the rest of the nodes, but this condition won't get true for them. So we'll get our answer for the deepest level, which is 4. Okay, so this was the in-depth code walkthrough of this algorithm. So let's discuss the time and space complexity trade-off for this solution. So time complexity is quite straightforward. It is O of n only. Like height function would also recur the entire binary tree, and after that this deep sum would again do its another iteration. So O of n plus O of n is O of n only. Okay, so space complexity, what is space complexity? Space complexity is proportional to O of h. So h is nothing but the height of the binary tree. Okay, height of the binary tree. So this was all I wanted to talk about this problem. Now there might be certain people who would be arguing that is it necessary to compute the height of the binary tree? Like, what I mean to say is that, can I omit this recur function and directly manipulate this single recursive call only to find the deepest level and the sum at the deepest level? Okay, you got what I am trying to say? Like, there won't be this additional recursive call. So this recursive call won't be there, and they are directly trying to manipulate this recursive function. So this you can take as your homework to try to remove this recur function and directly manipulate this deep sum. If you are not able to complete this, please add your understanding in the comment section, so I'll let you know the solution. So this was all I wanted to talk about this problem. So if you liked my interview style problem solving and code walkthrough, please subscribe to my channel Clean Coder. It would mean a lot to me. Thanks a lot for watching the tutorial.